Hi everyone, I'm Sebastien Ross. I work on the ASP.NET team, and today I will talk about output caching in .NET Core 7. So what is output caching and why do we want output caching? Output caching is about storing the results of your web applications instead of running them again and again. And by storing them, you can then get back some CPU cycle, get back some time, and have better performance overall for your web applications. Today, there is already some solution in ASP.NET Core to do output caching, kind of output caching, and it's called response caching. And there are some limitations with response caching. One main limitation of response caching is that you can't really configure how it works. What it means is that response caching in ASP.NET Core right now is about reacting to client headers and server headers, as in HTTP headers. And based on these headers that are sent or received from the server, then the response caching middleware will store the result and then serve it back again instead of producing a new response completely. So those response headers might be confusing if you need to customize the cache because you might not want to take them into account. So with output caching, you can just configure how you want it to behave, and it will just follow what you ask for and won't take those headers into account. Another thing that response caching doesn't provide you is to be able to store somewhere else than the memory. Right now, you can only store something in the memory with response caching, which means you might be limited in terms of available memory, but you might also not be able to share your cache across instances in case you want to scale out your application. So with this new middleware that we are building for .NET Core 7 is an ability to store the cache entries into different stores. For instance, the disk, because that's the most obvious one to store something. It's less limited than the memory. You could also store that to Redis or to blob storage if you need to scale out your instances and to share the cache across instances. And then it's completely extensible. So if you have other ideas or if you want to download NuGet packages to provide new stores, then it's totally possible. Another request we had to improve caching is to support tagged entries. When you want to store something and you want to invalidate the cache, because cache means also invalidating a cache, you need to be able to selectively say what you want to invalidate. With tagging, you can decide what part of your site has to be refreshed or revoked and regenerated. I will show you later in the demo how it works. And this could also say, you could also tag everything with the same tag if you want to refresh all the entries on your cache. But at least you have more granular control over what you want to be removed. A very important feature that we want to provide also is a mitigation for cache Stampede and Thundering Herd. So these two concepts are pretty similar. The idea is that imagine you have a website that is very, very well used and you have thousands of requests per second. Cache Stampede happens when you have a cached entry that gets revoked. And all the next requests will ask for a new response, a fresh response. It won't be in the cache, so the server has to process the request. And if you have 1,000 requests per second and your request takes 1 second, you might have 1,000 requests asking for the same thing while there is still no cache entry. And what can happen is that the CPU gets overused because so many requests at the same time occur. And that's what is called cache Stampede. It can take your server down if there are too many requests at the same time. And it's similar with Thundering Herd, which means when you have a burst of requests and you can't process it, and because too many requests at the same time needs to process the same thing. So to prevent that, we implement resource locking. Resource locking will allow the server to just process one request at a time if this had to be cached. And once it's done and it has a cache entry available that it will send to the first requester, it can reuse the same entry for everyone that were waiting for the same request to be processed. And this way, it's kind of locking, meaning only one at a time can process a resource or a page, and they will everyone on the client side will receive the same response. So that's something I will also demonstrate. Final thing I will show you is cache revalidation, which allows the clients to just get status codes about their request being available or not, or fresh or not. So instead of sending back the full body, we'll see how we can just send a 3 or 4 status code to let the clients know that they don't have to download the full body, they just have the fresh value on their side. So now let's switch to a demonstration about these features. So here I'm in Visual Studio 2022, and I have the application running. This application is very simple. So here we create the application, and we have one endpoint, which is the home page / that will render gravatar.writeGravatar. And what you can see here is every time I refresh the page, I have a new monster that is generated, and also the date, the time when it was generated. So how it works is just that it's generating an image tag with a link to the Gravatar website with a new GUID every time. And this GUID is hashed and generates a unique monster. But if you use the same GUID, you get the same monster. So just to show you when the page is a new page, regenerated, or reused page. If it was cached, every time I would refresh the page, I would get the same monster. But in this case, nothing is cached. So if I go back there and I want to enable caching, I will just invoke the output caching middleware. So in this case, we do builder.services.add output caching, which will register all the services required for the output caching, meaning the logic itself, and also the store, for instance, where to store the cache entries. By default, it will be in memory, but it's extensible. You can customize it. And then what I need is to plug in a middleware which will intercept the request and either return a cached entry or cache the entry itself. So here it's use output caching. If I run this, so it's rebuilding. If I refresh my page, I have a new one, and it's still not cached, because by default, the service and middleware are present, but they don't act on anything by default. So if I want to enable output caching on my home page, I need to invoke, in this case, .outputCache extension methods on the endpoint. And at that time, if I refresh my page, I click and I click again, I get the same response every time. So the server side doesn't process this entry, otherwise it would be a random monster. It just returns the same previous results as before. And hopefully it's also faster because it just has to take the results from a store instead of regenerating it. You can also see here a timestamp that doesn't change. Okay? And maybe that's not what you want. Maybe what you want is to enable caching for every endpoint by default. This is what I will be doing here by setting some options. And here, I can just say options.policies add enable caching policy. In output cache, the options will hold a set of policies that will define how the current request will behave with regards to output caching. Here, this policy will just allow the output cache to kick in for every request that comes in the middleware. So I don't have to say output cache on all the entry points anymore. It's up to you to define it as opt-in or opt-out. So here I say it's opt-out because I enable it by default on all my endpoints. And if I save it and I refresh my page, I have a new monster because the app restarted, so I have a new response. But now, every time I click, I have the same monster again and again. And at that point, what you might want to do is to say, no, I don't want that to be cached. So what you will do is, let me take that. You can do an endpoint that calls into output cache, but in this case, instead of passing no arguments, you can customize again the policy just for this endpoint by calling into extension methods. In this case, the noStore extension method will register a policy that will prevent this endpoint from being cached. So that being saved, if I go to the endpoint, no cache, I get the new response, and I refresh again, and this endpoint is not cached. If I go back to the home page and I refresh, this one is cached. Okay? So this is how you can customize which one is cached and not cached. Something that you might wonder also is, how is it cached? For instance, I have the home page, but what if I have a query string like color red? If I go there and I'll refresh, this entry is cached. But if I go to blue query string, then I have a new entry. If I go back to red, I have the same previous one. So the idea is that every entry will vary by the full URL, technically, like the scheme, host, port, path, query string. Everything will matter into the cache key. So every URL will generate a different entry, mostly. How to change that is by using custom policies that will change this behavior. So here, what I'm doing is a new endpoint called query that will vary by query named culture. By saying that, what I want to do is that all my entries will just be different if the value of the culture query string is different, and no other one. So if I go to saving my file, if I go to the query endpoint, I have one entry, which is cached. If I say color equals red, I don't have a different entry because it only varies by the culture query string. So if I try the culture query string, yes, I have a new entry. If I do en, I have yet another entry. If I go back to yes, I have the previous entry. And whatever I put aside as a new query entry, like color equals red, it won't change the result because it only varies by the query culture, the culture query string. And there is a way to vary by, like headers or custom values. Now, all these configurations, you might not want to define them by endpoint because you might want to share all these settings, all these profiles across your endpoints. So what you can do is use profiles. So here, I will use two profiles. I will create two profiles. A profile is a predefined set of policies that is named. So in this case, the profile named micro is a set of policies based on expiration a time. So I just say this policy will expire the cache for 1 second. And this policy could also have other things like the vary by query or any extension method that you can call in the output cache method. So here, micro is about caching for 1 second, and mini is about caching for 3 seconds. By default, during this demo, everything is cached for 1 minute. So, and the default duration is defined in this property if you want to change it. So if no custom expiration is defined, it will use the default. In this case, it will use 1 second for the micro and 3 seconds for the mini. So let's see how it works. If I go back on my home page, which is also cached, I have an entry. And oh, by the way, no. What I need to do is define a profile. So let's go on this thing, which uses profile micro. So on the profile endpoint, and I will refresh. And what I get is a new entry every second. And if I click faster, it doesn't change. It's only every second that I get a new entry. What happens is that after 1 second, it takes a cache entry, and it finds that it has expired. So it will say, don't use the cache, go on with the request, and it serves the request, which is cached for the next client. Okay. Now if I go and say, change this one to use the mini one, and I click, I get a new answer every 3 seconds. Okay, that's how you can do configuration out of the endpoints and reuse that. Also, a nice feature is that you could give it a different name like mini or micro, like default or whatever, and you have a central location to change how long it takes without having to change your code everywhere. So that's the nice thing about it. Another way to reuse profile is to use attributes. So instead of calling into the output cache method, you can, so I will show you here, there is nothing at the end. What you can say is add on your endpoint this custom attribute that will behave the same way as this extension method. And it's also very useful when you are in MVC to apply it to a controller or to a specific action and call into a profile. So in this case, the mini profile will be defined on this endpoint, but through an attribute. So if I go to my attribute, this is the mini, which means I get a new response every 3 seconds. Right? Now, tagging. So tagging, I explained earlier, is about being able to invalidate a specific section of a site. So how to do that? I'm creating 2 endpoints that will simulate a blog. I will have the blog endpoint to display the full list of blog posts, and a post endpoint with an ID to generate a new page for every URL of the ID. Okay? And they are both tagged with the blog value. So any page blog or any page blog post will have the same tag blog. So running that, if I go to my blog, I have a purple monster with red lips. If I go to a blog post, /1, I have this monster. If I go back to my blog, I still have, oh no, this is a different one. So here, I still have my old purple monster, and post 1, I have the same monster. So they're both cached. And what I want to do is evict all these post and blog in one action. To do that, we need to call into a purge API. The purge API is actually called evict by tag async. And it's available on the service named iOutputCacheStore, which is the store implementation or the service that is used to store and retrieve all the cache entries. So you can inject it into your endpoint and then use it. And it has an API to remove all the entries that are tagged with a special name. In this case, I'm creating a post request, a post endpoint that is called purge / the name of the tag. And why is it a post? Because usually you don't want to, it's an action, so you don't want it to be cached, for instance. And it's up to you to define security around this endpoint, like authentication or geolocation, to prevent anyone from purging any tag. It's your endpoint, you secure it as you want, it just invokes the API. This API could also be from an external process, like to refresh the cache entries every second, for instance, or every minute, preemptively, for whatever reason you want. It's just an API you can invoke. So here, with that, let's see how it behaves. I will refresh my log entry. OK, this is post 1, this is fine. This is in cache. And now I will use this client to send a post request to my endpoint with a blog tag. And I will send it. It says 200 OK. And now if I refresh, I have a new entry. I refresh, it's still cached. But if I invoke my purge endpoint, and now I refresh, I have a new entry again. So this is just to show you how, with tagging, you can selectively decide what section of the site you want to purge from the cache store. Now, tagging here is done on each endpoint with this extension method. So maybe what you want, and the section might be more than just 1 or 2 endpoints. It might be tens of endpoints, and you don't want to set the name here on every of these endpoints. So to be able to do that more easily, there is a way which is called a tagging policy. And let me show you how it works here. I'll take that and put that in my policy configuration. And what you can do is constrain a policy to a specific path, a specific section of your site. So here I'm using the tag policy, like in the output cache extension method. But before that, I say path/blog. So this policy will be applied to every request only if their path starts with /blog, which means the /blog page will be tagged, and the /blog/post will also be tagged. So I can start and remove that. I can actually remove all the output cache section here, like this. And I save my site. Everything under or below /blog will be tagged with blog. So if I refresh that, I have a new one. If I go to sender query to purge, I refresh, I have a new one. So this worked the same, but this time, instead of tagging a specific endpoint, I can define a requirement on my policy to only be applied there. And there is our other extension method to not just based on path, but custom code, just if you want to filter specific endpoints or reject any endpoint from being applied a specific policy. Now, let's talk about locking, which I explained was solving cache stampede and thundering herd issues. So locking. Here, I'm creating a new endpoint lock. And this endpoint, I'm missing something here. I need a request variable. So this endpoint /lock will take 1 second to render a number. So it's just rendering a number, and every time it's rendering it, it's incrementing it. So the first time I will see 0. The second time this endpoint is executed, I will see 1, and so on and so forth. In this case, I disable locking. Locking is enabled by default for every cached endpoint. I'm disabling locking here just to show you what happens when we don't have locking. And I say the cache expires in 1 millisecond, just such that it's cached, but so quickly evicted that the next time I refresh, even if it's cached, it's trying to get a new request, meaning it's trying to reprocess that, because I want to exercise locking, actually. So let's run it and see what's happening. Again, first, it's without locking. So if I invoke the endpoint, first request, I get 0. And I will hit refresh. 1 second after, because it takes 1 second, I'm getting 1. Refresh again. 1 second after, I get in 2. Now I will hit F5. If I click quickly on this button, it will actually stop the previous request. The cross will appear. So I will hit F5 just to see what's happening. I will hit the F5 button 5 times. 1, 2, 3, 4, 5 in less than 1 second. And what I see is it shows 7, which means all my requests were sent and processed by the system because the cache was only valid for 1 millisecond, and I don't type as fast as 1 keystroke per millisecond. So they were all going inside the endpoint here, the code, to be re-executed. And that's incremented, okay? So during the same second, 5 requests were processing in the same code. This can be an issue with cache stampede or thundering herd. To prevent that, I will enable locking, which is the default. So I could just remove this code, and it will be the same thing. And now I refresh, so the application restarted. So I have 0 again. I click once, I have 1. I click twice, I have 2. And I will do the same thing and type F5, hit F5 in less than 1 second. 1, 2, 3, 4, 5. And I'm getting 3. So what happened is that only one request went into this code, generated the result that took 1 second, but all the 5 requests that were being executed at the same time got the same result. This you can see very clearly if we open the DevTools. I go in the Network tab, and I click Refresh. I see 1 request, and I get the result here after 1 second. Now, if I do, oh, I don't want that view. Here, 1 second. Now I will do 5 times. 1, 2, 3, 4, 5. I will preserve the log. 1, 2, 3, 4, 5. You see my 5 requests were sent. Oh, yeah, that works. And only 1 was generated, and it took 338. The last one took 338, meaning between the first one and the last one, around 640 milliseconds were passed. And this one just took 300 milliseconds because that's when it started to hit the server, while the first request was still being processed. And the 5th request is actually getting the result from the first one, like the 2nd, 3rd, and 4th. But you can see the time here is just faster because it didn't have to process for 1 second. It just got a cached entry that was processed by the first requester. So that's how cache stampede works. Well, cache stampede mitigation, which means locking in this case. Now, let's look at response caching. So everything we've seen here would work also for response caching. As I explained earlier, response caching is the current middleware in every previous version of ASP.NET Core that allows for caching a response, but based on conventions, based on headers. So here, what I can do is configure the headers endpoint with a policy that is called the response caching policy, which is a policy defined in output caching that has the same logic as the response cache middleware. Because the output caching can also do, by configuration, what the current response caching policy is doing. And in this case, by doing that, it will only cache a response if the server sent the public cache control header to the client. Okay? So the middleware in between the server and the client, so the response caching policy, will then cache the entry because it says, oh, the cache is public, I can cache it. So let's run that. I will go to the headers endpoint, and if I run it, I have a new monster. And if I run it again, I have yet a new monster. So what's happening is that it's not cached, even though I can see in, so if I refresh that, headers, the response here, response headers, cache control public. So this and this header was correctly sent on the client, but the server didn't cache it. And the reason is that when the client sends a request, actually when Chromium Edge/Chrome send a request, what we have, so let's run it again, is we have a request header that is cache control max age 0. And because of that, the server won't cache or won't return a cached entry because the client asks for a fresh cache entry. So the server can't actually return the cached entry. And that's an issue with the response middleware when you do web pages and where you want sometimes to force pages to be cached. So to show you that it's actually the expected behavior, I will use this client, no headers, and this client, I won't send the cache control max age 0. And if I send a request, you can see the response here. This is cached. Every time I click send, I have a cached entry. Okay? But if I were to send this header, I'm getting a new entry every time. So that's how the response caching middleware currently works, and that's also why you might want to use the output caching middleware. Some people will be better served when they do web APIs, for instance, by the response cache middleware if they want to follow the RFC protocols. But it's up to you to decide which one you want. Now, related to cache invalidation, or to revalidation, we have the eTag support. So eTag is a mechanism to name a resource such that when you request the same resource, the server can tell you, you have the correct one, it didn't change, I don't need to send you the full body. So how it works is the server sends a header, eTag header, with a value that identifies the response. And here, let's run that and see what's happening. So I'm going to the eTag endpoint, refresh that. I get a cached entry. But what's interesting is that if I look at what is exchanged between the client and the server, and I refresh, I see that the response contains an eTag, which is here a unique identifier, and the request says if none match. So because the client received an eTag header, the next time it requests the same page, it will say, by the way, last time I requested the page, the eTag was that thing. So please send me the same resource, only if it doesn't match this identifier. It's like a hash of the response. And the server, because it sees that, and it sees that the cached entry has the same eTag as the one that was requested, the server will actually send a 3 or 4. And that's why here, we don't see that in this case, but let's see here, or because we have a max age probably, let's see there, eTag, I will remove this entry and I will send the request. Okay, this is cached. If I look at the headers, I have, so first, no, right, I have a 200 OK, right? 200 OK, I have the eTag that was set to that. Now I will send the same query, but if none match that, did I do it correctly? Looks like. I will send it again. And now, instead of having a 200, I get a 3 or 4. The 200 contains the fully cached answer, well, the full body of the cached answer. The 3 or 4 is completely empty. There is no thing to see. The server just said to the client, please reuse the code, the content you have locally. It didn't change since this eTag didn't change. Okay, so please reuse the same one. So that's how eTag is supported in this case. Another related header is the if modified since. So to show the if modified since, I just have a simple cached entry because it doesn't require any custom eTag in this case. So let's go onto this endpoint. It's working. I will actually use this client with the if modified since that will disable. I send it, and you see I'm getting a cached entry, but I'm getting the full body again. I'm getting the image tag, and I'm getting the text here. Now, in the response, it says generated at that time. I will copy that, and in my header here, I will send, just give me the content of this URL if the content hasn't been modified since this date. And if I send it, I'm getting a 3 or 4 because the content is cached and the server sees that it's actually not older than that, so you can use that. And if I do like 48, same thing. But if I ask something that changed before 46, like 45, oh, enter, sorry, send, I need to send the request. And I send it, and now it returns 200 OK with the actual content, okay? The cached content, but the full thing. And I think that's it. There is one thing I didn't mention, how to use the output cache, for instance, is when you have something like a CDN that needs to serve all the content of a site or part of the content of a site and serve it fast, you want like an edge proxy that contains all your content, that's what you would use. You would use output cache to be able to do something like this and decide what you want to cache, where you want to cache it, for how long, and then your edge proxy will be able to serve it much faster. That's how all the CDN works. So that was the demo. Now, what's next and what we still need to implement? So we need to implement Byterange caching, which is a way for the server to just cache parts of a resource you want to download. For instance, let's say you have a video and the client will just pick a bunch of, a range of bytes from this resource, and the server might be able to just cache this range. Or the server might be able to cache the full video and just give you back the range that was requested by the client. Another thing we still need to implement is response substitution, which will let you alter a cached entry before it's served to the client. The idea is maybe you might want to exclude some parts of the cached entry and replace it when it will be requested by something more fresh. Another feature is to provide more storage options. As for now, we just have the memory cache that is implemented. But when we ship next November 7, we expect to have also a disk-based solution to store on the disk, and probably also a Redis solution. And finally, we need to be able to return stale results when we do locking. So right now, when you do locking, and there are like thousands of requests waiting for the response, they will all wait for the response. And they have to do that. What we want to be able to do is to configure this to say that if you waited too long, just return a 404, just return to try again later, or maybe just return a stale result. Like, it might be fine while you are waiting for the new page to just return what was cached before that. And that's something that we want to also to implement. That's it. Thank you. If you want to follow this issue, how it's going, and all the features, or give feedback, please follow this link. If you want to contact me, I'm available on Twitter at Sebastien Ross. Thanks for your time, and I hope you will find this feature very useful. Thank you. Bye.